All right, so this year's Nobel Prize in Physics, AI. I get it. Seems a bit out there, right? But when I saw this, I knew we had to do a deep dive. This isn't just some physics thing. It gets to the heart of how we understand intelligence itself.
It's pretty mind-blowing stuff when you really get into it.
Totally. We're talking about John Hopfield and Geoffrey Hinton, two guys who basically laid the groundwork for the AI revolution that's, well, kind of happening all around us right now. And get this, Hopfield. He started out as a theoretical biologist.
Yeah, using physics to study the brain. Talk about thinking outside the box.
Exactly. And then you've got Hinton, a computer scientist, drawing inspiration from statistical physics, of all things.
Which is fascinating because it shows you the power of cross-disciplinary thinking. I mean, these aren't fields you typically associate with AI, yet here they are revolutionizing the field. And to think, Hinton also won the Turing Award.
No way. It's like winning two Nobels.
Exactly. A testament to the impact their work has had. But I'm sure some of you are thinking, okay, that's great, but what do they actually do?
I'm with you. Let's break it down. So Hopfield, back in 1982, he publishes this paper. Ready for this? It's about creating a physics model of memory.
Groundbreaking stuff. Imagine he basically envisioned the connections between neurons in our brains as physical forces.
Hold on, like magnets.
Exactly. Think about how magnets attract or repel each other to find a stable state. He used similar principles to model how neurons interact and form memories.
Okay, so instead of data being stored in a specific location, like on a hard drive, it's more about the patterns of these connections.
Exactly. And these patterns can be triggered based on similarity, what he called associative memory.
Oh, like how a certain smell can suddenly bring back a vivid childhood memory.
Exactly. It's not about the specific location of the memory, but the connections that trigger it. That's how our brains work.
Wow, that is so cool. But wait, so this physics model of memory, it wasn't just about explaining how our brains work, right?
You're right. This model actually helped physicists understand other complex phenomena in a new light. Things like phase transitions.
Phase transitions. Okay, you're losing me a little.
Imagine ice melting, right?
Yeah.
That change from solid to liquid, that's a phase transition. Hopfield showed how these seemingly unrelated concepts, memory and phase transitions, were actually connected on a deeper level.
Mind-blowing. Like finding a secret passageway between two completely different rooms.
Exactly. And that's where Hinton comes in. He took this idea of connections and really ran with it, applying it to the world of computers.
And that's where things get really interesting. But we'll save that part for after the break. So these layered networks we were talking about, they weren't just some abstract theory, right? This was the early days of AI.
Oh, absolutely not. This was leading to some seriously impressive breakthroughs even back then, like image recognition, for example.
Okay, computers learning to see, so to speak.
Exactly. Hinton's networks could be trained to identify and categorize images, and they were shockingly good at it for the time. I mean, really impressive.
Wow, so we're talking about computers actually seeing the world, kind of like we do. But wait, there's more, right? Didn't these networks also have this crazy ability to create?
You're right. One of the things that really blew people's minds was that after you fed these networks enough data, they could actually generate new examples of what they'd learned.
Yeah.
Show them enough pictures of cats, for instance, and they could start to generate their own totally new cat-like images.
It's like those AI art generators that everyone and their dog is talking about these days, but this is decades ago.
It is pretty wild to think about.
It really is. But you're saying this wasn't about, like, perfectly recreating a human brain in a computer, right?
Right, exactly. It's important to remember that these early networks, as groundbreaking as they were still very simplified models of the brain. Hinton actually made this comparison. He said it was like comparing an apple to a planet.
Okay, I kind of see what he means.
They're both round, right. But the level of complexity, totally different universes.
Right, right. Okay, so a good reality check. But even if they weren't perfect brain replicas, this was still a massive step forward.
Absolutely massive. What Hopfield and Hinton did was introduce this idea that, hey, computers can learn from data. They don't have to be limited to just following pre-programmed instructions.
Which seems so obvious now.
Right. But that shift in thinking, that's the seed that blossomed into the AI explosion we're seeing today.
Wow. So everything from ChatGPT to AlphaFold, all of that traces back to these early ideas about layered networks and learning from data.
It all goes back to that core concept.
It's pretty incredible when you think about it.
It really is.
It's not all sunshine and roses, though, right? I mean, didn't Hinton himself actually come out and say he was worried about how fast AI is progressing?
Yeah, he did. And, it's understandable AI has huge potential for good, but with that much power, well, there are bound to be some risks, something we have to think about very carefully.
For sure. You mentioned safeguards. What kind of safeguards are we talking about? What do we actually need to do to make sure this all goes in a good direction?
Well, first and foremost, we have to think about the ethical implications. For example, how do we prevent AI from being used to discriminate? How do we make sure AI benefits everyone, not just a select few? These are big questions that we really need to be grappling with as AI continues to advance.
Big, important questions. It's good to know people are thinking about this stuff.
Yeah.
Okay, so potential downsides, check. But there are also already positive impacts happening right now thanks to all of this, right?
Absolutely. And it's not just about having cool new tech toys to play with. AI is already driving really meaningful progress in things like scientific discovery. And those breakthroughs, they're going to impact our lives in a real tangible way.
Like what? Give me an example.
Well, look at astronomy. Astronomers are now using AI algorithms to sift through massive amounts of data from telescopes.
So instead of having, like, a whole team of scientists poring over images for months, the AI can do it in a fraction of the time.
Exactly. And it's not just about speed. Often, the AI is actually more accurate than humans. It means we
Wow.
can identify things like supernovae or potentially hazardous asteroids much, much faster and with more reliability.
That's huge.
Right. Early detection, that's key.
Totally. Okay, so astronomy, that's one example, but this is relevant to other fields too, right?
Oh, absolutely. We're talking medical diagnoses, climate modeling, drug discovery. These are all areas where AI has the potential to analyze information and make predictions with incredible speed and accuracy.
Yeah.
It's really revolutionizing how we approach these challenges.
So, like having a superpowered assistant helping us solve some of the world's toughest problems.
Exactly.
That's exciting. And it's not just about practical applications either, right? I mean,
Okay.
you were saying something earlier about how this work is also impacting how we understand the human brain itself.
Oh, yeah, for sure. Remember Britt Moser, the neuroscientist who won a Nobel Prize back in 2014?
Refresh my memory.
She discovered grid cells in the brain, these specialized cells that basically give us a sense of space. Well, her and her team actually used a modified version of Hopfield's network model to study how these grid cells help us navigate and create spatial memories.
Wait, so they're using AI to study the brain itself?
Exactly. And it's actually helped them make some really important discoveries about how our brains work.
That's wild. It's like using a mirror to get a better look at ourselves, you know?
It really is.
This Nobel Prize, it wasn't just a win for physics or for computer science. It was a win for our understanding of ourselves and our place in this crazy universe.
Beautifully put.
You know, when you really think about it, it's amazing that all of this groundbreaking work, all of these world-changing discoveries, they all started with two scientists looking at the same question from totally different perspectives.
It just goes to show the power of thinking outside the box, right? Connecting ideas from different fields. It's often in those unexpected intersections that the real breakthroughs happen.
It's like that saying, creativity is just connecting things.
That's exactly.
And this Nobel Prize is like the perfect example of that in action. It really underscores how important it is to be curious, don't you think? To be willing to look beyond your immediate field and see how different ideas connect.
100%.
You never know where those connections might lead.
You really don't.
So, as we wrap up our deep dive into the world of physics, AI, and the brilliant minds of John Hopfield and Geoffrey Hinton, I just have one final thought.
I'm all ears.
Think about your own passions, your own interests. What might seem like completely unrelated fields to you. Maybe there are hidden connections there just waiting to be uncovered. Keep asking those questions and stay curious because you never know, you might just stumble upon the next big breakthrough. You know, it's really amazing when you think about it. All of this groundbreaking work, all these world-changing discoveries, they all stem from two scientists who approached the same question from totally different angles.
It really speaks to the power of interdisciplinary thinking, doesn't it? Sometimes the most innovative ideas come from connecting those dots between fields that on the surface you wouldn't think have anything to do with each other.
Totally. Like, there's that saying, creativity is just connecting things.
Yes.
And this Nobel Prize is like the perfect example of that in action.
Absolutely.
Really underscores how important it is to, nurture curiosity.
Definitely.
And that willingness to kind of look beyond just your immediate area of expertise because you never know what those connections might reveal.
Exactly. Exactly.
So as we kind of wrap up our deep dive here into the world of physics and AI and the just incredible minds of John Hopfield and Geoffrey Hinton, I just have one final thought.
Get me with it.
Think about your own passions, your own interests, what might seem like totally unrelated fields to you. Could there be some hidden connections there just waiting to be discovered? Keep asking those questions and stay curious, my friend, because you never know. You might just stumble upon the next big thing.